This is continuing chapter 5.1. We're going to look at two objectives. Objective 1, applying the rules of probabilities, and 2, compute and interpret probabilities using the empirical method. So that's where we're going to go for next. And so when we're doing probabilities in this section, there are some rules that apply to probabilities, and they're labeled here, so you don't have to copy this down. But here's the idea that you have two rules to probability. One, of the probability of an event must be greater than equal to 0 and less than or equal to 1. So when we talk about probabilities, we use numbers to describe probabilities. We use a number between 0 and 1. And so probabilities, when we say, what's the probability of this happening? We usually say a number between 0 and 1. If we're going to communicate this to somebody, we then may turn that to a percent. So we got to get used to that idea. So that's one rule. The second rule is that the sum of all the probabilities must equal to 1 because that equals 100%. So if you have all these events, the sum of all those probabilities must be equal to 1. And then formally, we call this a probability model. We call this a probability model. Probability model, MODEL. Lists all the possible outcomes of a probability experiment and each outcome's probability. It's just organizing them. And a probability model follows these rules. There's some important notes down here to pay attention to. We use numbers to describe probability. Events impossible, we say it has a 0 probability. If it's certain to happen, we say it has a 1 probability of 1. And so make sure you're aware of that. Make sure you're aware of that important note. Another important distinction is something we call an unusual event. So when we're talking about probabilities, we're curious to know if an event is unusual, right? What is an unusual event? It has a low chance of occurring, or low probability of occurring. So as we were saying about unusual event, it has a low probability or low chance of occurring. So you might want to change that word chance. We could change that word to low probability of occurring. And statisticians usually have what's called cutoff points. These cutoff points right there, those cutoff points, we usually say 5% or 0.05. So if something has a less than 5% chance, we call that unusual. And so that's what we're looking at. I want to show you just a quick example, since I don't have it here, of what a probability model looks like. This is from the book. This here is a probability model right here. It's just a list of probabilities. So when buying a pack of M&Ms, for example, what are the probability that you get a brown or yellow, red, blue? This is the distribution. So it's almost like a frequency distribution, but it's just probability model, or we would call a probability distribution. And you can see it follows the rules here. That's what it looks like. And then when you add up together, it equals 1. And that each probability is a value between 0 and 1. So this is why this would be considered a probability model. Again, you can look at this in the book and has the definitions. And so you can see if we can define if something's unusual or not with a 5% cutoff. Let's look at an example real quick. The next thing is let's actually calculate a probability. And so the first method we're going to use is called empirical method. Explain how to approximate probabilities using the empirical approach. Empirical is just kind of another word for experimental. That would be another a word that you might hear. Experimental. And if you took Math 83, we talked about this in Math 83. And the way you calculate it is it's the frequency of the event divided by the total number of trials in the experiment. So you're just counting up how often something happens. So for example, in this first example, an insurance agency currently insures 182 teenage drivers. Last year, 24 of the teenagers had to file a claim on their auto insurance policy. Based on these results, because these are empirical data, That's the empiricals, experimental or numerical data, right? It's another way maybe you want to look at it. It's just a fancy word, numerical or experimental. Last year, 24 of the teenagers had to file a claim. So if someone had asked, what's the probability that a teenager will file a claim? We use capital P to ask the question, what's the probability that a teenager, this is the event E, files a claim, right? So we would use that notation. Probability, capital P, the teenager files a claim, would be 24 out of 182. And then you would go ahead and calculate that probability. And so we would usually like to put, probabilities can be reported as fractions, but they're more easily understood if you convert it to a decimal. And we do probabilities to 3 decimal places. So this would be 0.132. 0.132 is what we would put over here. 0.132. Or again, we would say a 13.2% chance. That's another way to report it, but we like to use decimals. Okay. Another example, here is an example of a probability model. There's a kind of a cool game. It's called Pass the Pigs. Instead of rolling dice, you roll pigs. And so what is the expectancy of that? I just want to show you what that looks like real quick. Here's the game.
And we're playing Pass the Pigs. Are you ready?
Yeah! I'm good, piggy.
Let's do it. We've got 2 piggies, and the way they land, there's these cute little pigs. And each one of them has a dot right here. And you roll them like dice. You get points, and you can either decide to keep your points or...
And so I'll take I have a pair that I'm going to take to class to show you when we get a chance. But you just roll them, and you get points for how they land. And so that's the question that's going on right here in this problem here. Looking at how they land. There we go. And so we have these different things, and they named them. So use the results of the experiment, empirical probability, to build a probability model for the way the pig lands. Estimate the probability that a pig lands on the side with a dot. And so what we have here is if we were going to build the probability model, what we would do is we would need to then actually have a column for probability. That would be another column for us. And so in total there were 39 rolls of the pigs. And so estimate the probability that a thrown pig lands lands on the side with the dot. Side with the dot is here. And so that probability would be 1294 divided by 3939, and then we would have to convert that to a decimal. And so if we were going to make the probability model, we would fill up this table here and finish that. Would it be unusual for a throw to land on a leaning jowl or whatever that is, right? And what you would do is 32 over 3939. We would have to pull up the calculator again. And so I'm going to do 32 divided by 3939. And so that equals 0.008 to 3 decimal places, 0.008. And so this here is 0.008, which is equal to 0.8%. And since this value here is less than 5%, this is 0.8%, less than 5%, we would consider this outcome here. This outcome would be considered unusual because it's less than 5%. If you're going to make the model, you would have to get all the rest of these decimals as your example, but that's a probability model.